section 2.5. This is, again, what we're going to do today is finding zeros, finding equations from zeros. So what we've talked about are, remember, when you have a polynomial zeros, what we are talking about with the polynomial are the places where it is crossing the x-axis. These are the zeros, right? Also, these zeros are also called roots. Roots. We also called these solutions. They had many names. But the zeros are these places where it crosses the axis. That's the goal, right? The locations of where the equation is equal to 0. When the y value equals 0. Or when the function is equal to 0. That's why they're called zeros, because it's the 0. It's where it crosses the y-axis, where the zeros are. And we have different types of zeros, right? There are types of zeros. There was real and imaginary zeros. And even in the real, there were rational and irrational. Right, we talked about this last time. And from this, we made our charts where we talked about how the number of zeros, right? The number of zeros is equal to the degree of the polynomial. Right, the total number was equal to the degree. For a polynomial, right, if we have like 4x cubed minus 6x squared plus 2, my degree is this 3, right? That's the degree. So that means it has 3 zeros. So there are all of this we talked about with rational zeros, with roots, with these equations. And the last thing to remember is that irrational and imaginary roots, these must come in pairs because it's a plus minus square root because of the quadratic formula. The irrational and the imaginary roots, if there are ever any of those, these two have to come in pairs. There's always 2 or 4 or 6. There's a positive one and there's a negative one for the irrational and imaginary roots. So all of this is what we've talked about so far. All right? Any questions or confusion about any of the features here? Our zeros, right? We know how many zeros the equation has. It's guaranteed to have 3 of them. If it's a cube, right, whatever the degree is, guarantees that many zeros. We come in these two, the irrational and the imaginary, come in pairs. You can have any number of rational, but the total has to be equal to the degree. And we made these charts, and then we used the graph to find out which version of the equation was correct, right? Which chart was correct. We looked and we saw if there were some imaginary roots, that means it doesn't touch, right? The imaginary roots are over here. Irrational is if the decimal is decimal never repeats. Decimal never repeats. And the rational is if it's like a regular, like a fraction, or a regular number. Square root of 2, plus square root of 2, minus square root of 2. Imaginary is like 3i, or negative 3i. Right? So Imaginary and irrational come in pairs, right? There's one positive and one negative. Real ones can have any number of roots. Okay? This is what we've done so far. And we use tools like synthetic division. We use tools like long division to cancel some of these variables and things like that. So here's what I want to talk about today, right? When we have these zeros, I'll say each zero represents a factor of the polynomial. Each of the zeros that you find represents a factor. So let's say that your zeros, let's say your equation was y equals x minus 5, x plus 1 times x plus 2. Right? Each zero represents a factor. So these are factors. This is a factor. The little parenthesis you have is one of the factors of the polynomial. It's like how you break apart the equation, right? If you have a whole equation, you're looking to see if you break it into these parentheses. So each of these factors represents a zero. And the reason why, you can think of this, right? You can imagine the reason why is because if the equation equals 0, right? If we have 0 equals 5, x minus 5 times x plus 1 times x plus 2, right? If our equation equals 0, if we make these three factors, this whole multiplication problem, equal to 0, then we have something called the zero product property. Zero product property. And the zero product property says if you multiply two things together, a times b, and you get the answer of 0, what is the only way that's going to work? What is the only way you're going to get 0 if you multiply this two things together, a times b? How can I get a 0 if I have a times b? What is the only way this is going to happen? If I multiply two things together and get a 0? Yeah. Right, Jasmine? The only way I'm going to get an answer of 0 is one of these two things has to be equal to 0. Right? Either A is 0 or B is 0. This is going to work. Right? I mean, it's sort of obvious if you think about it, but this is the rules of math. Obviously, the way multiplication works, when you multiply these two things together and your answer is 0, one of them has to be 0. I don't know which, but one of them has to be 0. And so the similar situation we have here. If I multiply a lot of these things together and my answer has to be 0, then one of these things is going to have to be equal to 0. One of these things has to make 0. So you can kind of imagine that, say, like, I have three options. Right? I have three options here. Either x minus 5 has to be 0, or x plus 1 has to be 0, or x plus 2 has to be 0. Those are my only possibilities. Right? If all three of these multiply together, these factors, if these factors multiply together and make a 0, then my only options are this part has to be 0, this factor has to be 0, or this factor has to be 0, or this factor has to be 0. Those are the only options I have. And so I am solving these equations. I'm solving this and saying, well, okay, this has to equal 0. If I add 5 to both sides here, x has to equal 5. That's one of my choices. Or if I minus 1 here, x has to be equal to negative 1. Or if I minus 2, x has to equal negative 2. And so these 3 possibilities are the zeros of my equation. And this means when I graph my equation, I'm going to have negative 1, negative 2, and 5. These are going to be the 3 places where my graph is going to cross the axis. It's going to look like that. My equation has to look like this because my zeros must be these 3 things, these 3 factors. Each factor connects to a 0. So one of them is a 5, one of them is a negative 1, one is a negative 2. And so a thing you can notice, a trick you can do is, you see here, x minus 5, my answer was plus 5. So all you're going to do to find the zeros, all you're going to do, right, to find the zeros, just switch the sign. Or I should say flip the sign. Flip the sign. Flip, oh my goodness gracious. Flip the sign of the factor. Flip signs, right? So if it was negative here, it becomes a positive, right? If it was positive, it becomes a negative. And so when you have your parentheses, you flip the sign, and you get, that tells you the locations of the 3 zeros, or however many you have, in your graph. So the factors tell us the zeros. Because of this zero product property, where we have to have one of these 3 has to be 0. And so they're all possibilities, so that's where our function crosses. And this is the fundamental theorem of algebra, right? This is identifying these zeros, locating these pieces. Okay? So zeros come from the factors. And the factors we can find in lots of different ways. Questions? It's okay? Oh, I keep forgetting I'm a bear. All right. So let's say that I want to find the zeros of a particular equation. So, for example, do it in wrong color. For example, find the zeros of the equation. So let's say I have y equals x minus 5. Oh, I already did that. Hold on. X plus 3. And then I have x plus 2i. And I have x minus 2i. And I'm also going to have 2x plus 1. I'm going to have these. What are the zeros of this equation? What are my zeros? Well, each of my factors tells me a 0. So this x plus 3, I know that one answer is negative 3. It's one of my zeros, because I just flipped the sign. X minus 3. If my factor is x plus 3, my 0 is going to be x equals negative 3. That's one of my zeros. One of the numbers that is going to cause this to be 0. In here, my I have an imaginary 0. I have a 2i and I have a negative 2i. And again, these two always come in pairs. So, but my answer works out to be the same. If I have x equals, if I have x plus 2i, well, my answer is just, I'm going to flip the sign. Negative 2i is one answer, and positive 2i is the other. So there's my pair of imaginary zeros. So even if it's imaginary, it works the same way. 2i, negative 2i. This 2x plus 1, well, now we have this 2 in front. So what's that going to do? How's that going to change my answer? How's it going to change my answer? Well, if we remember the rule said we have to make this equal 0. So if I say 2x plus 1 equals 0, if I solve this, minus 1 on both sides, that's regular, right? I minus my 1. I'm going to get 2x equals negative 1. So I have the negative 1. But now the 2, I have to divide that to cancel it. And so the 2 becomes the bottom of a fraction, the denominator here. So I'm going to get x equals negative 1/2. And that's going to become the 0 for this one. X equals negative 1 over 2. And so the 2 becomes my denominator of a fraction. And that becomes my other 0. 4 zeros in this situation. 1, 2, 3, 4. One of them is a pair of imaginary zeros. Pair of imaginary zeros, and then 2 others. 1, 2, 3, 4 zeros. So this is a quartic equation, power of 4 equation. Okay? But okay with that, right? If it's a 2 in front, right, there's 2 in front. When I divide it, becomes the bottom of a fraction. So whatever number you have here is going to become our denominator. Okay? Not hard, right? Just finding the zeros. But making this connection, understanding this connection that these numbers represent the places where the graph, right? These numbers represent the places where the graph is going to cross the x-axis. The imaginary ones are not going to cross. They're going to be some loop up above, right? We can look at this equation and find out what it's going to do. But that's the connection, right? So now the other side of this is, okay, what about making an equation? Whoopsies, wrong color. What about making an equation? Make an equation from zeros. So let's say that now we have zeros. Our x equals 4, x equals negative 1, and x equals negative 3. Now we're going to go backwards. I give you the zeros. I want you to make an equation from these zeros. So now we're going backwards. We're putting the answers, right? We have the answers, we have the zeros. We're putting those zeros back into a function, back into an equation. Well, to do that, again, all I have to do is each of my zeros is going to be a parenthesis. Each of my zeros is going to be a parenthesis. Each one becomes its own little factor, right? Each zero represents a factor. So this one's going to be here, this one's going to be here, right? Each zero is a factor. And to put it back in, I just have to flip the sign the other way. So if it's x equals 4, my 0 is going to be x minus 4. And flip the sign. Positive 4 becomes negative 4. X minus 1, x equals negative 1 rather. Negative 1 becomes a positive 1. Negative 3 becomes a positive 3. So here's an equation. There you go. There's an equation. I have all the pieces, right? All the factors are fine. But this is not really the final answer that I have, right? The final answer is if I turn this equation into a polynomial equation. And that's what I'm going to have to do. I'm going to have to take this, and I'm going to have to multiply to make a polynomial. So I want to get some equation that's going to have x to the third power plus a bunch of other stuff here. This is my goal. I want to make my polynomial. Want this. So if I start out with my factors, I'm just going to have to do some foiling, multiplying these two together, multiply these together, and work out to get this x cubed equation. So to do this multiplication, I'm going to multiply 2 at a time. Only multiply 2 at a time. Multiply 2 at a time. So I'm gonna sort of ignore this one for right now. Set aside this x plus 3, and I'm gonna do these two. I'm gonna do these two first. So I need to FOIL, right? X times x, x times 1, and then distribute negative 4 times x, negative 4 times 1. Do my multiplication. This times this, this times this, whoa, this times this, this times this. So I'm gonna get x times x is x squared. X times 1 is plus 1x. Negative 4 times x is minus 4x. And negative 4 times 1 is minus 4. And that thing is going to multiply by x plus 3. X plus 3. Right? So I'm doing 2 at a time. This one I can simplify a little bit more. Let's do this in black, and let me erase this stuff down here. So I'm going to keep going. I'm going to keep simplifying, keep multiplying. Try to erase all this. So these two add together. So I'm going to get x squared minus 3x minus 4 times x plus 3. And again, now that I have these two, I'm going to multiply again. Distribute my x squared times x squared times 3, and then negative 3 times x, negative 3 times 3, and then the negative 4 times x, right? I'm going to multiply all the pieces together, distribute the whole thing. What am I going to end up with? X squared times x is x cubed. X squared times 3 is plus 3x squared. So that's the x squared piece to both. Let's do my negative 3x. Negative 3x to negative x is negative 3x squared. Right, negative 3x squared. Negative 3x times 3 is negative 9x. Negative 3x times 3. Negative 4 times x is negative 4x. And negative 4 times 3 is negative 12. Whoop. Negative 12. So those are all my pieces of multiplication, multiplying these pieces together. So multiply 2 at a time, and then simplify. Simplify just means combine like terms. So here's my 3x squared minus 3x squared. These two are actually going to go away. Plus 3 minus 3, right? That cancels out. So the x cubed is part of my answer. These two combined together, negative 4, negative 9, that's going to make negative 13x minus 12. And this is my equation. Whoops. I should say y equals. This is my polynomial equation. And this graph has these three zeros, 4, negative 1, negative 3. So this polynomial here is going to cross at 4, at negative 1, and at negative 3. Okay. Should we check that? Let's go to. So I got x minus 4, x cubed. What was my equation? X cubed minus 13x minus 12. Come on. X cubed minus 13x. So we can see here's the zeros, right? The three places. Right there, and right there. If I do minus 12, my three answers negative 3, negative 1, and positive 4. This equation guaranteed to cross those three spots. Because we figured it out from the zeros, multiplied it all together, and got this answer. So this answer breaks up into those three pieces. Negative 3, negative 1, and positive 4. So that's the connection between polynomials and factors and zeros, how this all kind of world comes together. Cool? X cubed minus 13x plus 12. So whatever equation you get, right, let's go back to our whiteboard. Whatever equation you get comes from these zeros. And that's the equation that's going to have those as the factors, those as the zeros. So let's do one more. Find an equation. For example, find an equation. If my zeros are going to be, let me just check here. Oh, that's fun. Okay. What my zeros are 1 and 2i. What if the zeros I tell you are 1 and 2i? So I can start my equation. Each of these is going to be a parenthesis. So I have one parenthesis here, one parenthesis here. So my 1 is going to make my equation x plus or minus 1, everyone. Minus, thank you, Kermit. Yes, exactly, x minus 1. And this 2i is going to make, okay, that's an imaginary. Oops, that's an imaginary. But it works the same way. It starts with x. It's a positive 2i. I'm going to have minus 2i. But what am I missing? I'm missing something here. Something is missing. Anybody know? Anybody have an idea? I have only half of something. I've only got half of something. I'm missing another half. Yes, thank you, Nami. The 2i, right? What we said about imaginary zeros is they always come in pairs, right? So this, you have to make the pair. Also, automatically, if you see that there's a 2i, automatically you know there has to be a minus 2i. And so there has to be this x plus 2i automatically. Automatically fill in the pair. Fill in the missing pair. So your zeros, if there is an imaginary zero there, there is automatically both pairs. Automatically the other, that's not, it says pain. No pain. Pair. Maybe this is painful for some of you. I don't know. Does being a bear help? I don't know. Hopefully. Automatically you have a pair. So if there's one of the imaginary ones, there automatically has to be the other one. So you automatically fill in the missing pair. So if there's a minus 2i, there has to be a plus 2i. If there's a plus 3, a 4i, there has to be a minus 4i, whatever the pairs are, right? And then we do the same thing. We multiply these together. Multiply and simplify. So which ones should I multiply together first? Should I just do these two together first? That would be fine, but it would become, when you do this multiplication, you want to make it simple. I would always multiply your pairs together first. Your conjugate pairs. Always do this multiplication first, because it's just going to make your life easier down the road. So multiply these two pairs together first. 2i minus 2i. So I'm going to do these two. X times 2i, negative 2i, x, that times that. So we're going to have x minus 1 is going to be over here waiting its turn. This is going to become x times x is x squared. X times 2i is plus 2ix, or 2xi, doesn't matter the order. Right? X times 2i. Negative 2i times x is minus 2ix. And negative 2i times 2i is going to be minus 4i squared. Right? Do not forget that when you multiply I times I, you're going to get I squared. Do not forget that. Okay? So we're going to simplify this, right? We multiply these two together. We're going to simplify this. The 2ix and the negative 2ix, well, very nicely, these two are going to cancel out. 2i, negative 2i, those two are going to cancel out. And we also have to remember I squared. I squared, when we square the I, it changes. Right? Who remembers? What does I squared become? What was I squared equal to? We simplified this, right? We talked about our rules here. Yes, very good, Naomi. I squared becomes negative 1. So we don't use I squared, we use negative 1, and then multiply negative 1 times negative 4. So this is going to become x minus 1 times x squared. Minus 4 times minus 1 is plus 4. And so now we multiply one more time, right? We're getting closer. We want to create our equation. We simplified the squared pieces into x squared plus 4. And we got this x minus 1. Now let's multiply these two together. Multiply all those pieces. X times x to the third power, x cubed, x times x squared. X times 4, this is plus 4x. Negative 1 times x squared is negative 1x squared. And negative 1 times 4 is negative 4. So multiply these pieces together and get your polynomial down here. And this is our answer. This is our equation, right? These four pieces, these three pieces here. I want to make sure I put it in the correct order. Always make sure you are in descending order. Descending order. Meaning, like the biggest exponent first, and then you go down. So x to the third power is first, and then I have minus x squared, and then I have plus 4x, and then minus 4. And so this is going to be the equation that has the zeros of 1, and then 2i and minus 2i. This equation here, x cubed minus x squared plus 4x minus 4. This equation has these zeros here. Okay? X cubed minus x squared plus 4x minus 4. Let's check this out on Desmos. What's it look like? X cubed minus x squared plus 4x minus 4. So here's my Desmos. X cubed minus x squared plus 4x minus 4. Looks like this. So there's my 0 of 1. My other two imaginary zeros are locked away in the little loop, right? I only cross one time. But the other ones are, here's 4, that's interesting, crosses a 4. But the other two are locked away in the little like imaginary, right? Imaginary 0, probably right around here on the y-axis where it equals 0, right? Interesting. So that's this equation, kind of locked away. Right? My 1, 0 is right there. My imaginary zeros are stuck over here. Okay? So you find the equation by multiplying these things together. Let me go back to our whiteboard here. Right? You multiply the zeros together, you get all your factors. One more example. Let's get it a little more complicated. Find the polynomial. If I have x equals, my zeros are, let's say 3, 2 plus root 5, and 2 minus root 5. Oh boy, what do I do here? You know, let's add another 0. Let's add one of also, I don't know, a 5. 4. Let's do 4. So now I have 4 zeros. 1, 2, 3, 4 zeros. Let me put the 4 over here. Let me do this. 3 and 4. And these. So I got 4 zeros here. So that means my equation is going to be 4 parentheses. 1, 2, 3, 4. And I'm going to fill them in with all of the roots. My zeros is a 3, so I'm going to x minus 3. I have a 4, so that's x minus 4. These two are a little bit more complicated, right? Because there's like two pieces here. 2 plus 5 is one of my zeros, 2 plus root 5, and 2 minus root 5. This whole equation is one whole zero. 2 plus root 5 and 2 minus root 5. So how do I do this? Well, I'm going to have to change each of the signs. I'm going to have to change each of the signs of both pieces when I do my equation. So I'm going to say x, this is a positive 2, so I'll say minus 2, and that's a plus root 5, so I'm going to say minus root 5. I switch both the signs. And the same thing here. X, positive 2 makes this negative 2. Right? Negative 5 becomes plus root 5. So I switch both signs of this complicated piece, right? Switch both signs. So positive 2 becomes negative, negative 5, root 5 becomes positive root 5. So you switch both the signs. And then we do the same thing we did before where we have to distribute. We want to simplify. We would multiply all this together and do some distributing. Now, I have a lot of pieces here, so I don't want to do like 2 and then 2. Like, is there a way I could speed this process up? Yes, there's a way I can speed this whole process up. I can do these two together, because again, I want to do my conjugate pairs together, my same ones together. I'm going to do these two together, and I'm going to do these two at the same time. I can pair them up. These two are going to get paired, and these two are going to get paired. So I just multiply all these pieces together, and then in the end, my final two answers are going to be multiplied together for the whole answer. So let's do this together. This part's easy. X times x, x times 4, 3 times x, right? So this is going to be x squared minus 4x minus 3x plus 12. That's that piece. This one's going to have a few more pieces I got to worry about. I need to do this x to all three of these pieces. When I distribute, I need to distribute to everything. X times x, okay, that's x squared. X times negative 2 is negative 2x. X times root 5 is plus root 5x. Okay, now the 2. I need to do my negative 2 to all three pieces. You're just going to have a whole bunch of multiplying, everyone. Negative 2 times x is minus 2x. Negative 2 times negative 2 is plus 4. Negative 2 times root 5. Negative 2 root 5. Right. Radicals multiply just like that. And I have to take this radical 5 and multiply it by all the pieces together. Maybe I should have done different colors. It's too late now. Negative root 5. Negative root 5 times x is minus root 5x. Negative root 5 times 2, negative 2 root 5. Root 5 times root 5 is negative, well, root 5 times square root 5 is going to be square root 25. And square root 25 is just 5. So when I multiply two radicals together, the radical goes away. It just becomes a 5. So this is minus 5. Radical times a radical, radicals go away. Root 5 times root 5 is root 25, and square root 25 is 5. So basically the square roots cancel each other out. When you multiply two square roots, the squares are going to cancel each other out. And so I get minus 5, right? Because it was negative root times positive. Negative times a positive makes a negative answer. So we've got all these pieces. Let's simplify each of these down. Negative 4, negative 3, that becomes negative 7. So I'm going to have x squared minus 7x plus 12. This thing, x squared is by itself, so that's fine. Let's see. I've got a negative 2x here, negative 2x here. Those are all those. So that's going to be negative 4x. I've got a root 5x and a minus root 5x. Well, that's very nice. Those are gone. Positive root 5 and a negative root 5. Those should always cancel. And then I've got this negative 2 root 5. Oh, this should be positive 2 root 5. Because I did negative times a negative, this is positive 2 root 5. So I've got negative 2 root 5 and positive 2 root 5. Those should also always cancel. Your radical pieces, when you do this radical stuff, the radical pieces should always go away. They always should cancel. And then I've got a 4 minus 5. That should be minus 1. 4 minus 5 makes negative 1. So now I've got these two things. I've got this 3-piece here and this 3-piece here. And now my last step is to multiply all these together and get one big final answer. So, do my distribution. X squared times negative 4x. X squared times 1, right? And do all these 1, 2, 3 times each piece. 1, 2, 3 times each piece. A whole big multiplication. Let's see how fast we can do this. X to the 4th. X squared times x squared is x to the 4th power. X squared times negative 4x is negative 4x cubed. Right? X squared times negative 1 is minus x squared. Now, the next part. This one. Multiply all, I should say negative root 7, right? Multiply this one to all 3. Negative 7 times x squared is minus 7x cubed. Negative 7 times negative 4 is plus 28x squared. Negative 7 times negative 1, positive 7x. Great. Last one, the 12. Multiply the 12 by everything. 12 times x squared is plus 12x squared. 12 times negative 4 is negative 48x. And 12 times negative 1 is minus 12. So there was my 3 pieces all multiplied together. And my last step, as usual, is to simplify, to combine all the like terms. I only have one x to the 4th. That's the only thing of x to the 4th. X cubed is here. X cubed is here. Those are my only two. 7 and 4. Negative 7, negative 4. That's going to be negative 11 x cubed. I got x squared. I got an x squared. I got another x squared. Let's see. 28 plus 12 is 40. Minus 1, that'll be plus 39x squared. I got a 7x. And I got a negative 48x. 48 minus 7 is negative 41x. And then my minus 12 is all by itself. Whew. There we go, everybody. One big equation. 4 radicals. 4 factors, I should say. 4 zeros. 4 solutions. Because it's degree 4. Because we started out with 4 parentheses, we get our full equation right here. And if you want to check it, you can graph it. But this is what I want you to do for your assignments this weekend. We are just about out of time. Let me just tell you what your assignment is, what your homework is. you're going to be doing this multiplying and factoring, and you're going to be solving for the zeros. I would like you to, your homework, oh good, I'm just at the very bottom. It's 2.5b, page 144. Numbers, 1 through 4 all, and what I say, 39 through 46 all. 39 through 46 all. That's your homework. I will see you again on Monday, everybody. We'll check in with this. Once you're done, type goodbye in the chat. Once you type goodbye, you're free to go. I'll see you all next time. Have a great weekend. Stay safe this holiday weekend. I'll see you all next time.